mathematicians, it's Miss Allison here. Today is Thursday, April 16th, and we are looking at Series 3, page 1. Make sure you're looking at the correct page before we get started. Number 1 says, a model of a certain number is shown here. I see a visual of some 10,000s, hundreds, tens, and ones, and then it says, what number does this model represent? Let's go ahead and underline the question. The first thing I'm going to do is draw an extended hundreds chart. So we have our 10,000s is the biggest place value. We have thousands, hundreds, tens, and the ones place. Oops. If you didn't draw an expanded hundreds chart, go ahead and pause the video and draw one now. Then I want you to go ahead and plug in the numbers, unpause the video when you have an answer, and compare it to mine. Let's count how many 10,000 blocks we have to know what number needs to go in that place value. 4, 5, 6. So I see 6 10,000s. I don't see any thousands, so I'm going to put a 0 as a placeholder. Then we have 1, 2, 3, 4 hundreds. 1, 2, 3 tens. And 1, 2, 3, 4, 5 ones. So now I know I'm looking for 60,435 as my answer. I'm going to go ahead and check A. Looks like the thousands place does not match mine. They have 4 thousands and I have 0. So I'm going to underline that and then slash the trash. Let's check B. 60,435. Looks good. So let's magic maybe. C says 60,000. Looks good. 500s, 35. They got 500s, but we only had 4, so let's slash the trash. And then option D only has 6 thousands, but we didn't have any thousands, so let's underline that and slash the trash. B is the best option for number 1. I'm going to skip number 2 and go down to number 3. Number 3 says, the graph below shows how many minutes Heather practiced singing during the last 4 days. Which table on the right represents the data on the graph? Okay, I know we have a bar graph here, and we're looking for the table that matches the bar graph. So when we have a bar graph, we know the first thing we need to do is see what our y-axis is counting by. I see they're going up by 15, but there are 3 groups in the 15. So I have 15 divided by 3. I'm going to guess and check. Let's see, are we counting by ones? 1, 2, 3. That doesn't work. Let's check 2, see if we're skip counting by 2s. 2, 4, 6. That doesn't work. The next thing I always like to check is 5s. 5, 10, 15. Ooh, that works so far. Let's keep going. 15, 20, 25, 30. Looks good. So let's go ahead and fill in our y-axis. Skip counting by 5s. You gotta be careful. Keep your work nice and neat. It's a really tight space there. 35, 40, 45, 50, 55, 60, 65, 70. If you didn't label your y-axis or the values of each bar, pause the video, do it now, and then unpause the video after you've done those things. Now it's really easy for me to see that on day 1, she read 25 minutes. I'm going to quickly label the value of each bar. I see on day 2, she read 30 minutes. On day 3, we can see she read 50 minutes. And on day 4, I see that she read for 65 minutes. Okay, now we can go over here, and the question wanted to know which table on the right represents the data on the graph. We're looking for a table that matches this graph. So day 1, 25, looks good. Day 2, 30. Day 3, 50. Day 4, 65. A looks okay, so let's magic maybe and check the rest. B shows day 1, 17. Uh-oh, let's circle that and slash the trash. Let's check C. Day 1, 20. We got 25. I'm gonna circle day 1 and slash the trash. And then let's check D. I see on day 1, they got 25. That matches mine. Day 2, 30. Matches mine. Day 3, 55 does not match mine. We got 50, so we can slash the trash on D. And that makes A the best option for number 3. Number 4 says, Craig has the 56 tacks shown here. He will separate the tacks into 8 groups. He will put an equal number of tacks in each group. The question is, underline it, how many tacks will be in each group? Okay, so we know Craig has a total of 56 tacks. He's going to separate his 56 tacks into groups of 8, and in each group there's going to be an equal number. We know anytime in a word problem we see the word equal number, we're either going to be multiplying or dividing, because multiplying is repeated addition and dividing is repeated subtraction. So because there's an equal number of tacks in each group, I know we're either multiplying or dividing. Since we're starting with the total number of tacks, 56, and he's dividing them into 8 equal groups, let's make a division equation that matches this word problem. We have a total of 56 tacks, and then Craig is going to divide his 56 tacks into 8 groups. And we don't know how many groups that's going to make, but we need to solve for it. So let's say equals y. Now, some of you may already know this fact family. If you don't, make sure you're listening to your skip counting songs. If you listen to skip counting by 8s on YouTube over and over again without even thinking or showing any work, you would already know what y is in your head super quickly. For those of you who don't know this fact family yet, let's go ahead and draw it out. For those of you who do, I also still want you to show your work by drawing it out. We're dividing into groups of 8, so go ahead, come up here to the 56 tacks and divide into groups of 8. Circle groups of 8, and then count how many groups you made. When you're done, unpause the video and see if your work matches mine. Luckily, this problem is set up really nice to where there's 8 in the top row. So here's one group, here's another group, and I'm just going to keep going down like that, circling groups of 8. Okay. Each of our group has an equal number. They have 8. It's a total of 56, and now we just need to count how many groups we made in order to find y. 1, 2, 3, 4, 5, 6, 7. We found 7 groups, so we know 56 divided into 8 groups will give us 7 groups. So the best option is H. And finally, we're going to go over number 5. Number 5 says, Miss Toombs bought 12 packages of light bulbs. Each package contained 6 light bulbs. Let's also underline each package because that's important. And when she opened the package, she found that 4 light bulbs were broken. Uh-oh. The question is, how many light bulbs were not broken? To find how many light bulbs were not broken, we need to find how many light bulbs Miss Toombs started with. We know she had 12 packages, and in each package there were 6 light bulbs. Again, just like we talked about on question number 4, anytime it says each package had the same number, we know we either need to multiply or divide. So when in doubt, you can either draw it out, or you can just make an equation that matches the story and solve. I have 12 packages. Okay, I drew 12 packages here. I'll move this up. And each package had 6 light bulbs. Now that I've drawn a picture, it's really easy for me to see what we need to do here. I see we're not dividing. Instead, we're repeatedly adding 6 12 times or multiplying 12 groups of 6. You can add 6 times, or you could just stack your numbers, or you could draw an open array. I'm going to stack my numbers. I have 12 times 6. 6 times 2 is 12. So we put a 2, carry our 1. 6 times 1 is 6, plus 1 is 7. So she started with a total of 72 light bulbs. That's what this number gives us here. But then she found that 4 light bulbs were broken. you need to think, are we going to add or subtract the 4 light bulbs that were broken? The question is, how many light bulbs were not broken? So let's take away the broken ones to figure out how many are not. We have 72, take away 4. Let's go ahead and stack our numbers. 72, take away 4. You can't take 4 from 2, so I need to borrow from the 7. 6 10s and 12 ones. So 12 take away 4 is 8, and 6 take away 0 is 6. So 68 light bulbs were not broken. So I'll put 68 and then bubble in the circles that match my answer. Okay, let's keep going with number 12. This page is a little bit tricky because the first thing you're going to need to do is find the fraction. And then the second thing you're going to need to do is look for an equivalent or equal fraction. So let's go ahead and do number 12 together so I can show you what that looks like. Write these notes at the top of your page and then play the video again when you're ready to keep going. 12 says, what fraction of the figure is shaded? Okay, so I see 2 shaded pieces. Because there's 2 shaded pieces, I'm going to list that as our numerator or number on top. Then we need to count how many total pieces the whole is divided into in order to find the denominator or number on bottom. 2, 3, 4, 5, 6. So there's a total of 6 pieces and 2 are shaded. So now I'm looking at A, B, C, and D. And I'm noticing none of those match my fraction. So that tells me now I need to find a fraction that's equivalent to 2/6. Okay, let's check A. Does 1/3 equal 2/6? Set this up and then pause the video as you cross multiply and then check your work with mine. 6 times 1 is 6. 3 times 2 is 6. So 6 does equal 6. So I'm going to put a magic maybe next to A. That looks good so far. B says 4/6. And we're comparing it to 2/6. Because 2/6 is the fraction represented in this picture here. I forgot to label it. Does 4/6 equal 2/6? Let's check. 6 times 2, 12. And 6 times 4 is 24. And then you need to think, are 24 and 12 equal? I don't think so. Nope, so we can slash the trash on B. Let's check C, 2/3. And we're comparing it to see if it's equal to 2/6. Go ahead and cross multiply. 3 times 2 is 6. And 6 times 2 is 12. Does 12 equal 6? No. Slash the trash on 2/3. And then check D. 6, 6, and 2/6. Well, I know 6/6 equals 1 whole, so it's not going to equal 2/6 because these two don't equal the whole thing. We could check it anyways. 6 times 2 is 12, and 6 times 6 is 36. And think, does 36 equal 12? No. So you could slash the trash on 6, 6, which makes A the best option for number 12. You're going to do that on number 13, the same thing on number 14, and the same thing on number 15. 15 is a little tricky. Which fraction is equal to 1 whole? You have 3 pieces of pizza, and the pizza's cut into 6 pieces. Did you eat the whole thing? No. 1/6. Oh. If your pizza's cut into 6 pieces and you only ate 1, did you eat the whole thing? No. C says 6/6. If the pizza's cut into 6 pieces and you eat 6 pieces, did you eat the whole pizza? It's magic maybe C. And then D says 6/1. Well, 6 divided by 1 is equal to 6 wholes. And 6 wholes does not equal the same as 1 whole. If I eat 6 whole pizzas, I did not just eat 1 whole pizza, I ate 6. So I can slash the trash on D, and C would be the best option. The last one I'm going to do with you today is number 17. Remember, the expectations are that you are finishing the entire page, even though we're only discoursing a few of the problems today together. 17 says, what is the distance from 0 to point C on the number line below? The first thing I'm going to do is find point C on the number line below and mark a star on it. If you didn't, pause the video, find point C, and put a star or a dot. Okay, and here is 0. I'm also going to put a star there. So I know I'm going from 0 to C. And the question is, what is the distance? Okay, first I need to figure out what each of these spaces represents. From 0 to 1, our candy bar, or this number line, is cut into 1, 2, 3, 4 pieces. That's our denominator. And this represents 1 out of 4 of the pieces. So when we hop from 0 to B, we hopped 1/4, which tells me when we hopped from B to C, we also hopped 1/4. So then if I'm hopping from 0 to C, I'm hopping 1/4 plus another 1/4. If I hop 1/4 plus 1/4, we add those. When we add fractions, we're only going to add the numerator because the denominator tells us how many pieces this is cut into. Just because we're adding these two pieces together, we're not cutting it into more pieces. So we're only going to add the numerator together when we add fractions. 1 plus 1 is 2. And then your denominator stays the same because still our number line is split into 4 pieces. So it's 2/4. But now I need to go down here and check A, B, C, and D because I don't see 2/4. So you need to go and find an equivalent fraction.
Hey, you guys, also don't forget, you only get 60 seconds for part A on NHM and then 60 seconds for part B on NHM. Count how many you got correct today and then set a goal for tomorrow. Every single day, you should be just getting a little bit faster until you're reaching your goals. Keep up all your hard work, 3rd grade.